Okay, students, this is 2012 problem number 6 that we're going to be looking at right now. And it talks about a particle from really time from 0 to 12. And it says that the velocity function is equal to cosine of pi over 6t. And the position is -2 at time equals 0. So that means that x is equal to -2 at time equal to 0. So that means it starts out with a position at -2. Okay, and there we have it. So it's time to kind of move along with this. You should recognize this because this is what your Riverwind problem. It says for time 0 to 12, when is the particle moving to the left? Well, that's when v of t, the velocity function, is negative. So you want to know when is v of t negative. So as you look at cosine of pi over 6t, what we need to do is consider that graph. Now, in this case, for this example, they wanted you to do everything by hand. My guess is on this test, you get to use your calculator for it all. I know the graph of cosine goes up to 1, it goes down to -1. And what I'm going to do is I'm going to determine here, I'm going to determine the period. And period is equal to 2 pi divided by b. Your b value is pi over 6, or multiplied by 6 over pi instead of dividing by pi over 6. Those cancel, I get 12. So it looks like it goes over 12 units, which is nice because we're going from 0 to 12. So cosine starts up here, dips down, and comes back up like that. So we're wondering, where is it negative? It looks like from 3 to 9. Um, v of t is less than 0 when 3 is less than t, which is less than 9. So from 3 to 9 is when you're talking about. Part B says right, but do not evaluate. An integral expression gives a total distance traveled. Distance is different than displacement. Distance is the absolute value of the velocity function, and you then use that integral symbol. Okay? So distance is equal to the integral, and it says from time to 0 to 6. So we're looking 0 to 6, absolute value of the velocity function dt. So distance is different than displacement. If it said displacement, you would get rid of the absolute value sign. Okay, part C says find the acceleration of the particle at time t. So acceleration at time t is equal to, move this on up here. I'm going to try to adjust this focusing. Okay. Acceleration at time t is equal to v prime of t. So if you consider your velocity function, find the derivative. I'm going to set up the chain rule here. We have cosine of u, and we have pi over 6t. So pi over 6 is my derivative for the inside, and the negative sine of u for the outside. So therefore, the derivative is, in this situation, negative pi over 6 sine of pi over 6t. And that's your acceleration. Okay? Now the question is, find the acceleration. We've got that. Now it says, is the speed of particle increasing or decreasing or neither at time is equal to 4? So v of 4 we're going to check, and then we're going to check a of 4. We're going to check both of those. V of 4 would be the cosine of 4 times pi, sorry, I'm off the grid there. 4 times pi over 6. And 4 times pi over 6 is going to give me 2 pi over 3. Or the cosine of 120 degrees. Cosine of 120 degrees, if you consider that type of triangle, you have a terminal point of -1/2 root of 3 over 2. So therefore, v of 4 is -1/2. A of 4, you're going to look at this guy right here. So negative pi over 6 times the sine of 2 pi over 3. You notice 2 pi over 3, that's going to give you the sine value, or the y value, which is the root of 3 over 2. So negative pi over 6 times root of 3 over 2. which is negative as well, negative pi roots of 3 over 12. So therefore, the speed of the particle is increasing at time equals 4 because A of 4 and V of 4 are same sign. And that really takes care of letter C for you there. Okay, a little bit involves some trig, stuff like that. You're totally capable, you can do it. And then part D, find the position of the particle at time 4. This is a little bit more involved here. Time equals 4, we want to find position. Position is equal to start plus displacement. Okay, so our start is, if we look back here, is at negative 2. So we have negative 2, and the displacement is the integral of the velocity function, or in this case, cosine of pi over 6t, okay, dt. And we're going from 0 to 4 because we want to be able to find the location at time 4. So I need to find an antiderivative. In this case, I have to use substitution. U is equal to pi over 6 t, so du is equal to 6 over pi dt. I don't have a 6 over pi here, so I need to multiply by pi over 6. Du is equal to just dt. What? Totally wrote that backwards because I'm thinking ahead. So pi over 6 dt, so we have a 6 over pi du is equal to dt, excuse me. So in order to determine that integral, I have the integral 6 over pi of cosine of u du. And the antiderivative of cosine is sine. So we have 6 over pi sine of u, which is, in this case, pi over 6t. So that's my antiderivative. So I'm going to take negative 2 plus that 6 over pi sine of pi over 6 t. And I'm going to evaluate that at 4 and at 0. Now, all we need to do here is just plug in 4. And so you have the sine of 4 pi over 6, or 2 pi over 3. We've already determined that. The sine of 2 pi over 3, we said, was the root of 3 over 2. So we get negative 2 plus 6 over pi times the root of 3 over 2. And that will suffice. You don't have to simplify it anymore. That answer is absolutely fine. So don't worry about trying to make a simplification. If you want to find common denominators, you could. But in that situation, you plugged in really everything that you need to. Everything that you need to. I'm just going to really quick here just check and make sure that our work is right. Negative 2 plus 6 over pi, root 3 over 2, yes. Speed's increasing for part C, that's correct. Absolute value of the integral, that's correct. And this occurs, yep. So we got 100% on this problem right here. Again, we started off with 2 examples of speed, motion, velocity. These are, over the course of history of the AP exam, one of the top 3 types of free response questions. So that'll just hopefully set you up in case you see that with these 2 very well. Good to see you.